The Hyperloop Deployable Wheel System, or HDWS, is designed for the low speed requirements of the Hyperloop and also for emergency scenarios. It is inspired by a traditional trailing arm landing gear, and it is designed to fill the low space constraint of the Hyperloop itself. It is scalable in design, and it follows a plug and pin approach such that it's fully electric, and it's very modular in the sense that it can interface easily with other Hyperloop designs. As you can see here, this is an image of our Hyperloop deployable wheel system in the fully extended position and the fully retracted position. From fully extended to fully retracted, it takes about 2.5 seconds. Several components of our deployable wheel system use advanced manufacturing techniques such as additive manufacturing. The extension and retraction mechanism of our Hyperloop deployable wheel system is also fully electric, and it uses several feedback sensors to control the height of the Hyperloop pod. The active feedback control has a hybrid suspension system that consists of a shock-absorbing strut dampening vibrations. We also made use of various industry standards and hardware that allowed us to create a product best fit for the Hyperloop.
By focusing on a single subsystem, we were able to go into greater detail in the design process, generating detailed part drawings, assembly drawings, and CAD models. These parts were also analyzed using classical methods and FEA methods. So when it was time for us to use aerospace standard hardware in our design, I contacted the Aerospace Industries Association for help. They set us up with Cadena's Part Solutions and IHS Markit, which enabled us to access the Aerospace Industries Association's standards with 3D models. We then applied these 3D models in our native CATIA application to the Hyperloop deployable wheel system concept. We had the ability and the time to generate detailed part drawings, assembly drawings, and even perform classical and FEA analysis on each of our components. Our custom manufactured parts were designed to the highest detail and specs available on the market through our sponsors, and we used certified aerospace components such as NAS and MS parts whenever possible. While on internship, I learned the importance of using aerospace standards in the design and analysis process. Naturally, when we were developing the Hyperloop deployable wheel system, I wanted to incorporate those practices to make our design as high quality as possible. To give you an idea of how important standard parts are in our design, one Hyperloop deployable wheel system consisted of over 200 parts, 160 of which were standard parts, and of that 160, over 120 were NAS, AIA standard hardware parts. In fact, the AIA NAS standard parts represent over 58% of our total part count.